So I'm Harsha Kolli. I work for EverZinc Corporation. I am their battery technology lead. So I lead all the rechargeable battery materials division, essentially on the technical side. So like a technical architect, if you can say, on generating the next solution to our customers on rechargeable zinc batteries. So that's our main focus area, or my main focus area within the company. We are one of the largest zinc supplier in the world, or I would call it usable zinc supplier, right? We are not miners, but we convert that mined material into a usable zinc in different forms, like zinc powders, zinc oxides, alloyed powders for battery grade materials. So all that is part of our portfolio. Of course, we are developing specifically rechargeable grade zinc materials that can cycle more, the utilization is better, that can suppress the dendritic growth. 3 technical challenges with the zinc anodes, right? That's our main focus right now, to create materials that deliver on those 3 major things. If you look at zinc batteries as a whole, one of the major losses that occur is dendritic growth, right? So we have additives within our materials that actually suppress the dendritic growth, right? And there is passivation that occurs within while you're cycling the zinc batteries. Again, our structure and additives with the zinc powders help with the reduction of those issues, right? So we are the anode side of the equation, right? There's also electrolyte and cathode and separators that also play as a system. What we are focused on is how can the anode make the difference? It can, like what is the breadth we can improve it. And we only think about high volume. All our plants are 25,000 tons, 30,000 tons. So we are ready for where this battery is going to go, right? That's who we are. We are already supplying to the primary battery industry about 30,000 tons or 25 to 30,000 tons. So we can supply more than that to the rechargeable industry once they are ready for taking up that material. So if you look at battery developer, they have so many things that they need to work on to make something that is commercially viable, especially in the ESS space or the data center space, right? You have the electrochemistry part, which is anode, cathode, separator, electrolyte, all things that go into the cell, and then you make it into a block of modules, and then you make it into a pack, and then you have a battery management system, which for zinc is different than your standard lithium system. So you need to develop your own system for the voltage range you're operating on. And then you have to work on systems, and then commercialization, scaling, production. There's so many aspects of the industry, like of the battery developer's workload, that is too high for them to concentrate on improving, let's say, the anode, or improving the electrolyte, or improving the separator. It's technically, if you do all of that by yourself, it's going to take about 10 to 12 years, right? What can we do as a supplier, and what can we do as suppliers all together as a group, collaborate and bring the timeline to maybe 5 years, right? How can we improve on the electrochemical side? What can we give them? What can we give the developers, like tools to play with, so that they can improve their product and accelerate quicker to commercialization? Instead of focusing on that, they can focus on commercialization, production, scaling, right? All those are bigger challenges to solve as well. So just balancing that act. As an industry, we are able to get only 20 to 30% of the utilization out of our zinc, but we can improve that, right? Even 5% change at a system level will give you a drastic improvement in the total energy of the or total levelized cost of storage. That's the term that we keep using. So that'll be reduced substantially, even with a small change in the utilization of anode material. So that's our perspective. And of course, there is electrolyte perspective, separator, cathode perspective, which is different. But that's one key point, right? how structures can play a key role, how change in material shapes can play a key role in the process, in the performance, improve the whole output altogether. So that's the approach that we see as zinc material supplier. Battery is a system and not just one component of a system. Octet is the electrolyte part of the system. When I talk about collaborating, Octet is electrolyte, we are the anode material supplier. Those two need to talk to each other, right, as a system to work properly. Right? Additives play a very critical role in actual net performance of the cell and stability of the cell. So that's where I see I'm excited about Octet, bringing up those challenging solutions. Even small minor improvements on a whole at a system level will give you a large change. Net output will be much higher. So, and Octet being a molecule company, they're focused on that to make that big change with small molecules, right? That's the exciting part about working with Octet or about their technology itself.